All right, so we're going to look at this next video tutorial covering algebraic proofs, two-column proofs. And this is dealing with the algebraic proofs. There's some that have to deal with more of solving equations. Some of them have to do with more literal equations. But the idea is still sound in the sense that what we're trying to do is we're given a statement. We're trying to prove what it's asking us to prove. And we provide reasons behind each step that we take that proves beyond a shadow of a doubt that our answer is correct. So it's not just solving it. We're given reasons. We're given reasons why for each statement that we make along the way. Okay, so this is typically what it looks like, and I'm not going to go over every question because of time. I'm just going to go over hopefully 4 of them, and we can kind of see how it works together. Okay, so I'm going to do number 3 if you want to follow along in your notes. And the idea behind this is we're given some kind of a statement. In this case, we're given 4x minus 6 divided by 2 equals a negative 9. And we want to prove that, therefore, x equals a negative 3. Okay? Now, not always, but in some of these examples, they may list the statements for you. There are times where you're going to have to solve it yourself, and you'll have to provide the reasons as well. But in this case, they do provide us the statements, and we just need to provide the reasons behind each statement. Now, the first thing you may notice is that A is the same thing as we're given. Okay, well, that's the key word here. All we need to put down for A, the reason, is that that's what we're starting with. That's what we're given there. Okay, that's our starting statement. Now, the next part, the key is just like we would normally solve. When we go through those 5 steps like we talked about earlier, checking to see if there's the distributive property, we'll notice no, there's not. Checking to see if I can combine like terms, I can't do it to the left or right. Then we talked about we would pick a variable side and pick a number side. Well, if I keep x's on this side, just like on the problems we solved with multi-step equations, when we have to multiply by 2 to both sides in order to get rid of division by 2, to undo division by 2, well, yeah, and that's what's happening here. A negative 9 times 2 gets us to 18. So they're providing you the statements. They're providing us the next steps as we move along until we get to the final answer. But we have to provide the reasoning behind it. Well, what steps did we have to take in order to get to that step? In order to cancel out this 2 to undo 2, negative 9 times 2 to get to negative 18. Well, if you remember back from the last video, the multiplication property of equality says I can multiply the same number to both sides and still maintain equality. So the multiplication, and I'm going to abbreviate this because I'm going to run out of room here. The multiplication property of equality says that I can multiply the same thing to both sides, and that's what allows us to get to part B. Okay, well then think about what would we do next? Well, we said we would always have to move all the numbers to one side and get x by itself, but we pick the number that is furthest away from x, right? Well, how do I move negative 6 over to a negative 18? We would have to add 6 to both sides, right? Okay, so we'd add 6 to both sides, and then we would get 4x is equal to, well, what's a negative 18 plus 6? Well, negative 18 plus 6 is negative 12, okay? So how did we go from part B to part C? Well, we added 6 to both sides. Well, what property, what reason do we have that lets us know that we can do that? Well, the addition property of equality. The addition property of equality says I can add the same thing to both sides and still maintain equality. And then lastly, we have 4x is equal to a negative 12. Well, going back to our solving multi-step equations, we know that 4x really means 4 times x. Well, how do you undo a 4 times x? You divide by 4, right? Okay, and then we would get x on the left side, and what's a negative 12 divided by 4? Well, that's our x equals negative 3, right? But what property allows us to divide the same thing to both sides? The property is the division property of equality. The division property of equality. Okay, and then we get our answer, x equals negative 3. But now we have proven that this is true. We have given reasons behind why we can use each step. So there is no doubt in our minds that this is correct. Therefore, and that's what this guy means, okay, if you want to add that to your notes, Okay, that's what these three dots mean. Therefore, our statement is true, x equals a negative 3. Okay, asked and answered. That's another way you can put it, is asked and answered, or QED. But let's not worry about that. Let's just focus on the three dots. Okay, now I'm going to go over hopefully 2 or 3 more here. Let's go to, which one did I have? Let's try number 5, okay? So let's look at number 5, and I think the reason I picked this is because it works it a little bit differently than we're used to, and I wanted you to see that sometimes we can work problems differently. So we're given that 3 times x minus 2 equals 42, and we want to prove that x equals 16, okay? So again, we start with the given statement, what we were given, okay? And then we have to figure out, how do I get to the next step? Well, normally when we solve multi-step equations, we said check to see if you use the distributive property. Well, if I distribute, when we get 3x, 3 times x is 3x, and 3 times a negative 2 is negative 6, right? Is that what part B says? Well, no, that's actually not what it says. So what could be going on? Why is it not showing the same thing we would think of when we apply the distributive property? Well, check this out. Notice this is the same, right? So what is missing from the first statement to the second statement? 3. Well, how do I get rid of 3? What is attaching 3 to the parentheses? What operation? Multiplication, okay? This is 3 times that guy. Well, how do you undo multiplication? Division. If I divide by 3, doesn't that cancel that out there? And then, like we talked about, if you do it to one side, you got to do it to the other side. Check with your calculator here. We get x minus 2 equals 42 divided by 3 equal 14. Yeah. Now, what property did we use that allowed us to do that? The division property of equality, okay? The division property of equality says I can divide the same thing to both sides and still maintain equality. Okay, last one here. How would we get x minus 2 equal to 14? Get the x by itself? Well, we'd have to add 2 to both sides, right? Add 2, and that's where this 16 comes from. Well, what property allows us to add things to both sides? The addition property of equality. Okay, so then we end with our statement x equals 16. So now we have proven that x equals 16 based on our reasoning, so therefore x equals 16. Oh, that's a bad equal sign. There we go. X equals 16. Okay, let's see if we can try a couple more. I want to try number 8. Okay, now this is what we refer to more as a literal equation. So in this case, we don't actually have any numbers here, but we can still apply the same process. Okay, we just might not combine all like terms together. Or I shouldn't say that. We might not combine all terms together, but of course we can combine like terms, okay? So now, again, we're given that m is equal to at plus h, and we want to prove that m minus h divided by t equals a. So again, we start with our given statement, what we started with, and now let's think about, I have to get to m minus h divided by t to equal a, right? Well, what steps do I have to take to go from A to B? Okay, well, let's think about this. What is different from A to B, or how would we normally think about moving over a piece of the puzzle? Okay, so the best way to kind of approach this is we're trying to get A by itself, right? So just like when we were, get rid of that line. Just like when we were trying to get x by itself, we worked away from x and picked the number that was furthest away from x. Well, we're going to do something very similar here, and instead of working towards a, in this case the value that's closest to a, which is t, we're going to work furthest away from a, and notice that it's plus h. Well, what's the opposite of adding h? Minus h. I can subtract h from both sides. Doesn't a plus h and a minus h cancel out? Well, yeah. And then I get m minus h. We moved h to the other side, okay? Just like what we were doing with solving equations, okay? But now it's moved to the other side. Well, what allows me to subtract h from both sides? The subtraction property of equality. Okay, the subtraction property of equality. Okay, so I worked with that letter that was furthest away from A. Well, now I have to deal with the letter that is attached to A because we want to get A by itself. Well, what does AT mean? What is the operation between them? Well, multiplication, right? Well, how do you undo multiplication? We divide. Okay, so we're going to divide T away from A, which would cancel out, but whatever I do to one side, I got to do to the other side. Well, now notice it's starting to line up here, right? Well, what allows us to divide T from both sides? The division property of equality. Okay? So, we have now shown that m minus h over t is equal to a. Therefore, we have shown that m minus h over t is equal to a. If I can write a t, there we go. So, we have proven what they asked us to prove. Okay? Now, the last one I wanted to do, I think, and I should mention, these are the ones where you're going to have to write your own two-column proof and actually solve, but we'll get some practice in class. But I also wanted to try one with some substitution. There we go. Number 18. Let's try number 18. Okay? So, on number 18, we're given that g is equal to 2h. G plus h is equal to k, and k is equal to m. So we're given three different statements here from the get-go. And we want to prove that m is equal to 3h. Now that might seem a lot, but it's really not as bad as you'd think. Really pay attention as we go from A to B, okay? What the changes. So first of all, we start with the given. We had three given statements. Now, on part B, it says 2h plus h equals k. Well, that doesn't match any of the statements, right? But look at this. It is very, very close to this guy right here. Well, what could be happening? The only difference here is that this has a G and this has a 2H, right? Well, what's happening? Well, notice, what does the first statement say? It says G is equal to 2H, right? Well, by the substitution property of equality, by the substitution, and I should actually write this out to not confuse it with subtraction, substitution, there we go, property of equality, okay, says that I can substitute one equal thing for another equal thing. So I can replace G with its equivalent 2H. I'm just replacing G with 2H, okay? So that's what's happening there, okay? Get rid of all those marks. So we replaced G with 2H, and that's the substitution property of equality. Now, going from B to C, and even before we do that, let's just think about it, okay? 2H plus H. Well, isn't that 2H plus 1H? Which makes 3H. That's combining like terms, okay? Combine like terms. We're just adding them together, okay? So we get 2H plus H is 3H equals K. And then notice going to the next statement, it replaces K with M. Well, what allows us to do that? Well, notice the third statement says K is equal to M. So can't I substitute M into K? Yeah, it's an equivalent statement. It's saying 3H is equal to K. Well, if K is equal to M, then that means 3H is equal to M, okay? And we could actually say the substitution property, or we could actually say the transitive property. I'm going to say the substitution property. We're just substituting one equal thing to another. But sometimes there's actually a couple different statements that we could use in place, okay? I'm substituting M for K. Okay, so we substitute that value in, and then lastly, what is the only difference between D and E? Well, they just flip the statements, right? Well, if you go back to your notes, remember that's the symmetric. That's the symmetric property of equality. Okay, if A equals B, then B equals A. So therefore, M equals, whoops, there we go. 3H. Okay, so this is all I wanted you to do for now. Monday we'll work on this. Tuesday maybe we'll work on it a little bit more, and then I'll give you the key to check your notes and check your answers.